welcome to today's meeting. Yeah, a very warm welcome to all of you joining us for the SRIP 2025 guest talk, which is proudly organized by Pahal Horizon. Yeah, I am Mercy Samuel, and I'll be your moderator for this enlightening session. And and it's truly an honor to be part of today's discussion, which promises to be both timely and transformative. And you all know our theme of today, which is Introduction to Waste Management and Circular Economy in Urban Systems. Yeah, so as we continue to witness rapid urbanization across the globe, the importance of sustainable waste management and circular economic models has been more pressing. And efficiently, urban waste systems are not just about keeping cities clean, they are crucial for achieving a long-term sustainability, reducing carbon footprints and enhancing the quality of urban life. Hope I'm still clear. Am I clear?
Yeah, we can hear you. Thank you so much.
Thank you. So, and I've said, and who better to guide us through this important topic other than our distinguished speaker, who is Dr. Deval, a renowned expert in environmental science and engineering from IIT Bombay, Hawaii. Yeah, so this is the biography of our speaker today. He holds a PhD in environmental science and engineering from IIT Bombay, where he was awarded the Prime Minister's Research Fellowship and a gold medal for academic excellence. He currently serves as the Managing Director of Balaji Plastics and Environmental Services and Technology, which is a startup incubated at IIT focused on sustainable waste solution. With over 20 published papers in high-impact journals, several patents, and active involvement in more than 10 major R&D projects, including collaborations with institutions like CSIR, NEERI, and the University of California. Yeah, so our speaker today brings both academic depth and real-world impact to this conversation. And before we begin, I kindly request all participants to remain muted during the talk and to avoid background noises or else disturbances. And feel free to use the chat box for any question or reflections. You'll have a chance to engage with our speaker today during the question and answer session at the end of the talk. Lastly, as I finish, I want us to prepare ourselves to gain invaluable insights that could shape the future of our cities and our environment. Yeah, and I want you to join me as we welcome our speaker today. Dr.
Thank you so
Deval.
much. Yeah, thank you so much, Amasi, and the anchor. If I have wrongly pronounced your name, I'm really sorry for that. And it's really feel very good to be part of the Pahal organization and giving me this opportunity to be presenting some of my key knowledge aspect of my experiences from this domain for this particular session. So should I start or you to just interact with students first and then we have to go ahead?
You can start.
Okay. Just sharing my slides. I hope you can see this. Is it visible?
Yeah, it's visible. We can see it.
Yeah, thank you so much for assisting me for this. Most of the, first of all, really thankful for all the kind words that the anchor has already delivered about me. It's just a small span of experience that I've gained in this domain. Again, reintroducing myself, I am Dr. Deval Singh, and I've currently completed my PhD from IIT Bombay. My major segment of research dealt with waste management and circular economy, particularly in urban premises, urban area, specifically for developing country like India. Prior to that, I've done my master's in environmental engineering, and I started my career as BTech civil engineer, and then getting deep dive into environmental engineering. I did my master's at CSIR Needy, where I got to learn a lot of insights into my research findings, which I would be definitely sharing in my coming up presentations. So, starting with today's presentation, my topic would be to delve into the basic fundamentals of waste management and how the circular economy is an essential part of sustainability and waste segment for urban premises or urban areas. So, talking about the initial global scenario, we all know solid waste has been a growing concern, specifically for developed and less developing countries. So, Asia has a number of developing countries and some of the underdeveloped countries too. So, as you can see in South Asia, the production of the solid waste has been substantially higher if you compare it with the developed countries. If you compare it with US, Latin America, Northern America, the production is quite less. And the specific composition also varies depending upon the country's economical growth and its population aspects. So let's compare the waste generation from Indian cities or India's to the US-based cities or countries. You will find that the organic fraction of waste is substantially higher in country like India, Bangladesh, Pakistan, or maybe Africa. It's substantially higher because the living standard, the type of things we consume, the types of aspects that we look into is totally different. So as you can see over here, the larger portion is covered by the food and the green waste. Apart from that, there are a lot of fraction of paper products, plastic products. However, this segment of waste gets varied. It's totally different when you come out to for the Northern America. In Northern America, the production of organic fraction is literally very low, and a very high fraction of waste comprises of inorganic fraction, mostly the packaging products, tin cans, and those things which are readily available for them. So the fraction of inorganic fraction is substantially very low. So that's how the overall global scenario is different. So if the waste characteristic is different for a specific country, its treatment, its handling perspective, its handling approach will be different. So let's assume US prefers doing incineration as the most suitable method of treating its waste, but it can't be the feasible technology for Indian context. The reason is very simplified manner that the waste gets generated in US has less amount of organic fraction, moisture content in it. So the energy required to burn or incinerate is substantially very less. But if you compare with the Indian countries, the moisture content is really very high. So the energy required to incinerate these kind of waste will be very high, and ultimately it will affect the economical perspective of the urban local body to handle or treat this waste. So this is just a background, a certain background to give you an idea how population and economics plays a vital role in waste management and its production and generation. So just to give you a simple idea, what has been practiced over the year, the solid waste management has certain segments, certain stages. The first one is storage and collection. We prefer to collect the waste from our household. First thing is that we do first. Secondly, once we have collected, we like to transport it. Once we have transported it, we like to give it to the respective treatment facility, and some of the waste gets treated. Over here, the treatment prefers to be like getting it disposed of properly, getting it eradicated properly. Let's assume we send it to incineration plant. So it's a kind of treatment facility. So whatever the waste comes out from this incineration facility, because after incineration, there is going to be the ash content. This ash content will be further sent to the disposal facility. So where we have to landfill it. And finally, in some cases, not everything can be incinerated or anything can be treated or composted. So there we have to go for recycling. So let's assume the glass bottles coming out of your home, plastic products coming out of your home, plastic bags coming out of your home, newspaper, paper, these kinds of products can be recycled very efficiently. So majorly, there are 5 stages: storage and collection, transportation, waste treatment, recycling and reuse, and then disposal. In some cases, some of the cities, what they have done, they have merged their stage 3 and stage 4 to avoid the cost effectiveness. But the problem arises once these two steps get mixed up, the productivity of treating it gets reduced. And in some of the cities, in tier 3 cities, mostly tier 3 and tier 4 cities in country like India, there are only three segments. The first segment is collection and storage. The second one is transportation. And the final one is the landfilling. So there is no treatment facility. So let's assume 100 kg of waste coming out from a colony is directly disposed of to the landfill sites. So that's the bad part. That's what the problem with terms of solid management arises. So this is some of the hierarchy that usually the developed countries like US or European countries like London, they are following it. So first, they try to prevent these kinds of generation. Let's develop a product which has minimum wastage coming out of it. That's the prevention part. We have to minimize it, even though if it's get reduced, have a sophisticated system, have a sophisticated assembly line which can minimize the production of wastage or waste product. And the third step is to reuse. We have to reuse these kind of commodities again and again. What we do with the PET bottle is one of the example. Again, we can recycle it. Again, whatever is left out, in case not everything can be recycled every now and then. Let's assume, let's take an example of PET bottle. The PET bottle can be recycled maybe once or twice. After that, the grade of plastic it has, it reduces its strength to be recycled again. So in that case, we have to go for the energy recovery facility. And final one, the ash coming out of these kinds of facility need to be disposed of. The landfill is mostly preferred for the inert matter. It should not be preferred for high grade quality of waste. That's what the fundamental idea is. So some of the major sources. So where does this waste comes out into play? Where does this waste actually get produced? So there are some examples. So basically from the mining activities, there are a lot of waste coming out of it. So you can see over there, I've listed waste rocks, trailings, mine water, chemicals, and others. There are the agriculture and forestry waste, where you find the waste coming out in the form of organic, plasticizer, containers, manure, slaughter waste, and other kinds of organic fractions, maybe some feedstock or agriculture residues. Then we can see industrial waste. So the industrial waste is one of the most complicated category of waste, which I personally find out, because every industry have the waste in a unique manner. So let's assume the tannery industry will have a waste production certainly different from the industry producing a textile waste. So that's what the challenges is with the industrial waste. Second is the household, commercial, and governmental bodies waste. So this is nothing but a municipal solid waste. So the waste getting produced from residential areas, the houses where we live in, the residential establishments on the daily basis which we produce is nothing but the household waste. We call it as a municipal solid waste. We also call it as MSW waste. Then the new category of waste, which over the years have been a trending issue, is the construction and demolition waste. So the problem with the construction and demolition waste is this: once a new infrastructure has been built, the waste gets generated. If the old structure gets decimated and then again it gets converted into a new structure, again a waste is generated. And the problem with these kinds of waste is that its complexity. Now, initially, we used to have bricks and muds to frame a structure, but now we have concrete. Now we have plastic into it. Now we have wood into it. We have binders into it. So these are highly chemical extracts which cannot be segregated or which cannot be reused directly. So C&D waste is one of the issue. There is also one issue with the wastewater treatment plant. So whoever is somewhat new with this term of wastewater treatment plant, so the sewage which we generate from our household toilets, or we can say the sanitation waste, has to be treated. We call it as a sewage, basically sewage. So the waste, once it's get treated into a common facility, which we call it as waste treatment facility, it produces at the end, once the water gets recycled, there are certain organic fraction into it. So we call it as a sewage, and it gets transformed into sludge. So this sludge is also part of solid waste actually. So again, it comprises of high chemicals, it comprises of heavy metals. So if it's get directly disposed of at the landfill sites, there is going to be a lot of issues in terms of contamination. Again, this is a small summary. These are the major sources and the major types of waste. You can, yes, in terms of Indian government aspect, in terms of developing countries aspect, there are MSW, industrial, There is also a biomedical waste from hospital, the waste get discarded. There is also a new category, we call it as an e-waste. So again, this is a new category of waste, and hazardous waste. So we haven't talked about hazardous waste. So basically, hazardous waste are nothing but sometimes an overlap with the industrial waste. Let me give you an example. So there is a industry, there is a pharmaceutical industry producing a waste which comprises of high percentage of ammonia into it, or a high percent of fluoride into it. So now this waste gets transformed into a category of hazardous waste. Any element, any chemical element which comes into contact into the environment and it produces any kind of reactivity or any kind of health issues, direct health issues, can be considered as a part of hazardous waste. So going up further, we have learned about what is waste, how the things globally work in the waste sector. What are the segments of the waste management? We have got into that. What are the major sources of waste that get produced actually on daily basis? And now we will be talking about some basic gaps. If the system is already present in the environment, why the problem gets arise every now and then to manage this waste actually? So there are certain gaps actually. Because of this, we are not able to manage our waste properly, and that's where the environmental issues comes into play. The CO2 emissions, the high CO2 emissions comes into play. So the first gap, which over the years, which the literature has reported, is that lack of appropriate social culture interpretations and understanding of waste and waste management segment. So basically, to give you an example about this, the major problem in the context like country like India is that we don't have a source segregation facility. So a person generating a waste has to be reliable enough to segregate its waste by himself rather than relying on the urban local body to do that. So unless the waste gets segregated at its source itself, it can't be treated appropriately. So this is one of the gaps which over the years we have tried as a researcher, as a government bodies, we have tried to resolve it, but we have been not able to do that. Secondly, the domestic waste thrown on streets. So again, this is one of the area where I have done my PhD actually. We call it as littering. We call this term as a littering. So when the waste get directly disposed of from your home to the streets, we call it as a littering part. So again, n number of cities, majorly tier 3 and tier 4 cities, usually practices these kinds of habits. So this is also one such issue. Thirdly, industrial waste disposal in the open area. So now the new SWM rules. So these are the new solid waste management rules. So under this, the industry developing a waste, producing a waste, need to have its own treatment disposal facility. So let me give you an example. In 2019, I was working with, I was doing my internship with Mahindra and Mahindra. So the plant which I was working in, they had a production line of tractors. So they used to produce tractors. So there used to be chemical extracts coming out of in the form of solid waste. So they have bought a land specially near to their site. They have particularly bought a land to landfill these kinds of waste. So now you can't dispose your waste in a land which is given by the government to you. It's your responsibility being an organization. You have to have your own land. You need to have your own treatment facility. You need to have your own handling facility. So the big companies, what they do, they try to manage their waste at the source itself. They try to reuse it. So this is one of the major issues. The big companies are doing it. Most of the big companies are doing it, but the smaller one, we have A, B, and C categories of industry, especially in India. So the A categories, the premium one, are doing that, but the B, C, and D are not doing it appropriately. They get skipped out anyhow because of the loopholes in the system. One more issue is the segregation and storage of waste. Again, the similar to what we have said, the social cultural understanding of people toward waste is very minimum. Again, there is one more such issue of street sweeping. In most of the cities, we can see that the street sweeping facilities are very good in the premium areas where a big, what I can say, big giants live in. Somebody from good powerful area lives there. So there used to be always a maintenance of hygiene and all, or some tourist place. There will be a good hygiene place. But if you see the normal places in that cities are left out without sweeping, so that's one of the problem. Again, we don't have enough transportation facility. So it's very important if the waste is generated from 100% square area of a city, the collection rate needs to be 100%. The transportation need to be 100%, because if we are not able to collect it efficiently, we won't be able to process it efficiently. The final one is regarding the biomedical waste disposal in municipal waste streams. So again, the biomedical waste also comes into a kind of the category of hazardous waste. So it's a very sensitive waste. It has different categories of waste. It has different color codes. It has yellow, red, blue, white, these kinds of categories of waste. So for the white, you can see the what I can say, the instruments used for surgical analysis. The disposed part of those kinds of instruments are found in white category. In terms of red category, it comprises of the highly infectious organic matter or the highly infectious organic residues discarded from the operational activities, is a part of biomedical waste. So again, we need to have a very sophisticated and well managed infrastructure for it. So again, we lack this kind of infrastructure. Just to give you an example, for a city A, let's assume there are hospitals of around, let's assume a rough figure of 100 hospitals producing 1,000 tons of biomedical waste. And we have a common facility with one just simple incinerator having a daily treatment facility of 100 tons per day. We are shortage of 900 tons per day of processing facility. So we have enough production, but we don't have treatment for them. I would be talking about biomedical waste in my coming up slide to give you better clarity on it. So solid waste generation in India. So I have kept it in a context with India. I know there are students from across all the globe, but to just give you a background, a close understanding of how the country like India, the developing country like India, have a solid waste management scenario. So we have a collection rate of 96.8%. Again, these are reported values from CPCB report. We can only just follow them. We can't, what I can say, critically evaluate them, or we can critically question them. Actually, these are just reported value. I don't know how correct it will be, but still it's reported. We will affiliate that these are the true values. So we have a collection rate of 96.8%. We have a treatment of 47%. So again, almost 50% of the waste has been left out without treated. Then the 25.8% is the unaccounted. That means it cannot be processed, cannot be recycled. And then 27.8% is being sent to the landfill. We are never sure that this 27% is actually 27 or maybe more than 50%. So it depends upon cities to cities how they manage. So this is some of the basic stats that over the years how the population density has varied. What are the number of ULBs? What are the composting facilities that we have in India? So we have currently 95 such facilities. Okay, again, this value can vary because the data is around from 2020 to 2022. So slightly some values might get increased, might also get reduced too. So there are ULBs which are focusing on composting and vermicomposting facilities are 173. Operating pipe composting facilities, operating RDF, operating biogas plants, energy generation plants, solid waste generation, its collection rate, and its treatment facility. These are some of the basic stats which will give you an idea how the states or the country work in this domain. So coming up with my first agenda, my first part of this segment is the municipal solid waste, the waste which gets produced from household activities. So what are the roles and responsibilities of different stakeholders? So again, there is in waste management, actually there are different bodies which look after how the things get managed. So over here there are three major bodies. The first is the central body, the second is state body, and then is the local body. So the central body, just to give you an example, the central body, we have central pollution control boards. So the hierarchy follows in such way: the central body is at the top, the state body is at the mid, and the local body is at the bottom. So the point of contact for a normal resident is the local body, not the state body or the central body. Okay, so the person who is coming to collect your waste is from the local body, is not from the state or central. So the central government body, some of the examples are CPCP, MOUD. So these are the basic bodies. So the major roles of these bodies are to look into some rules, regulations, to standardize basic process, how the things can be worked in a better manner, to accumulate funds to support these rules and regulations. And while in case of the state body, the basic examples are State Pollution Control Board. Normally, each state have its own pollution control board. where they ensure that these guidelines given by the central bodies can be promisely followed by the local level bodies, by the state bodies, and they also have the right to establish an authorities, a sub authority, to have checking or the counseling over the local bodies. So again, the local body are nothing but your ULB, actually urban local bodies. They implement the guidelines and they try to follow whatever is instructed by the higher authorities. If they have been instructed with these funds, you have to manage this category of waste first, and then this category, they are the one who will do that. So just to give you a schematic diagram how the things work, I have presented over here. So the waste storage and collection by the civil body, and then waste loaded by dumping by the civil body. And there are different sources which we have already talked about: the market streets, the household streets, the sweeping streets, some unauthorized dumping area. These are the transfer station. So again, the transfer station, the concept of transfer station is used in two ways actually. The first way of using transfer station is to divert your waste. So let's assume there are 10 wards in a city, and the five wards have a centralized transfer station facility where the waste will come from these five wards and will get collected, will get dumped, or will get stored at the transfer station, and then it will be diverted to the landfill site. So basically, the number of transfer station in a city will vary depending upon the wards and the geographical status of this city is. So let's assume in a city like Mumbai, Mumbai has 3 ULBs because Mumbai is very big, so to manage it's really difficult. So they have 3 different ULB bodies, and each ULB have 5 to 10 transfer stations accordingly to synchronize the complete collection and transportation scheme in a city. So again, there are certain stakeholders. So the waste which gets collected at the household level, recovery of the rack pickers from the dustbins, recovery from the rack pickers from the dustbins, again the transfer from the rack pickers at the transfer station, and then dumper pickers. So basically, the idea behind using the word rack picker is that there are two segments in waste management again. There are two bodies which handles these kinds of waste. So the first body is the ULB, which does for you. The second body is the informal sector. The plastic waste recyclers are one of them. So they will just pick their waste from the cities at the outskirts or within the city area, and they will try to send it to the recyclers. So they are not get paid by the ULB actually. They are independent workers who work for themselves. So what the ideology says that they need to be affiliated to the ULB, they need to be affiliated to the centralized facility, and they need to work with the coordination with the ULB also. That's how they think can be synchronized, and a benefit to the rack pickers, both informal and formal sectors can be done. So what are the impacts of MSW management? Okay, why MSW management is so important? So basically it creates harmful health impacts. As you can see over here, how the landfill looks like. A lot of pollution, lot of groundwater. So basically, the major problem with the landfill is that the waste, the emissions which occurs from the landfill sites is very harmful. It comprises of CH4. So CH4 is nothing but methane and CO2. So these are one of the high potent greenhouse gases, and the waste gets piled over the years, and it produces leachate actually. So this leachate gets penetrate into the groundwater and it contaminates the groundwater. So ultimately, if the groundwaters get contaminated, whatever we are going to drink is going to be the heavy metals and persistent compounds, and again we are going to be ill. So if the groundwaters get affected, that's the major damage that we can have. And in currently the country like India, we have more than maybe 100 to 200 landfill sites currently in India. So that was all about MSW. So now coming up with some new category of waste which has been generated over the years, which is e-waste. We call it as an electronic waste, the waste which get produces from your cell phone, from your computers, from your speakers, from your kitchen appliances, anything you can consider, which has the electronic component, which works on electricity. So this is known as e-waste. So it has been estimated that around 3.2 million tons of waste gets generated in India itself. So we rank around third in the world. So there are certain consumers. So there are certain parts from where it gets produced. So the first is the household appliances. So from the household appliances, your mother must be using what I can say. They must be using mixer. They must be using fridge. They must be using ovens. So once its lifespan ends, it gets discarded. So these kinds of waste are also the part of e-waste. So we consider it as an household appliances. The second one is information communication systems. So these are nothing but your laptops, consumer electronics. So this under this consumer electronics, the cell phone is one of the basic example you can take it. The others might be your earphones is the one of the example. Your wires, your data cables is also one of the examples. So these are some of the basic sources. I have just elaborated the key players in e-waste management, how they work, how they should be worked actually in a synchronized manner. So these are some of the organizations which are working to reduce the e-waste management or to have a facility to manage this e-waste. So actually, why we need to manage this e-waste? We can directly burn it actually now. If we have a e-waste, let's burn it out. Why we need to just collect it and do all those things? The problem with the e-waste is that it comprises of certain metals. And when I talk about metals, it's not about iron and steel. It comprises of gold and silver too. So your cell phone which you're using in, it has 1 to 2% of gold into it. So gold is a kind of metal which allows a good conductivity in the circuit board designing. So that's why it's very important. So if it has high valuable metals, let's extract it, let's have a business out of it, and let's reuse it. So that's the idea behind it. So this is how the other ULBs are working together with some private and NGO organization. And there are R&D facilities, autonomous bodies who are doing R&Ds to recover the metals from these e-waste actually. So let me give you an example. One of my colleague, one of my senior, she was working on trying to extract gold and silver from the motherboard, from the laptop motherboard. So she has done her PhD under that. So she was able to do that around 80% of the extraction she was able to achieve. So through hydrothermal chemical reactions. So it is an high and heated reaction under which she will melt the complete what I can say motherboard, and then she will do some chemical reaction into some catalysis she will use, and again they will be able to extract the metal out of it. So this is how the R&D people are working into it. So this is all about the e-waste, and there are certain e-waste recycling facilities. Over the years, since 2020, there has been certain recycling uh, industry which have been continuously working on it, where they have been using the domestic consumers, government bodies, and private companies, where they have scrap dealers, traders, producers, company recyclers, and again, they follow certain process actually. The first process is manual dismantling, then they will follow recycling, and then hammering. So this need to be done physically actually, because if you look at the circuit board, it has a small encryption into it. You cannot pass through a machine and remove everything. It's very difficult. You have to do it manually. You have to remove manually. You have to visually look into the elements, and then you have to remove everything. So then we have acid leaching process. Then finally the left out waste products are went through the open burning and washing out of waste scraps, and then the leftover water residues has been discarded. This is all about the unauthorized recycling facility. This is mostly done in Delhi region. So in Delhi, we have unauthorized recycling facility, a big unauthorized recycling facility near Balsava landfill site. And if you talk about authorized facilities, there are certain startups which are working into it, where they use mechanical separation process. So where they will look into dismantling, sorting, shredding, ball milling, etc. And then phytometallurgy, they will follow. This is the process of extracting metals out of it, extracting components out of it. There is also a hydrometallurgy process. There is also biometallurgy process. So if you talk about pyrometallurgy process, so this is the heating process where the oxygen is simultaneously provided to the reactions. When you talk about hydrometallurgy process, a water-based heating process is preferred. Biometallurgy process, it is nothing but biological enzymes will be used to remove these kinds of elements. While in case of the electrometallurgy process, we will be using electrons, we will be using catalysts, we will be using rods, we will be using cathode and anode reactions to remove all these ingredients out of it. So this is all how the e-waste recycling facility works. And after e-waste recycling, the most trending, the most what I can say hyper-rated one is the plastic waste. We all know about plastic waste, how China, India, US, they are one of the leading producers. But if you look at some of the stats, which will certainly be out of the box actually, you can see how US has been managed. They follow incineration a lot. the recycling is substantially low, and a landfilling has a big proportion of it. Again, if you look at China, the recycling gets increased, the incineration is less, and the landfilling is again less. The similar trend is what we follow actually in India, but the difference between India and China management policy is that we fail to collect most of the fractions of our plastic waste, while China has been able to do that efficiently. They have been able to collect these kinds of waste maybe around 20% extra what we are not able to do that. So we need to have a policy where we can collect these kinds of waste in an efficient manner. So coming with the global waste generation, around 2016, it was around 2.01 million tons, and it is projected to cross maybe around 4 to 5 million tons in coming up years. So again, we need to have policies which can be more refined toward plastic collection and its treatment. Currently, Maharashtra is one of the leading one in terms of plastic production, then Tamil Nadu, and then Gujarat, then followed by West Bengal and Karnataka. So again, plastic waste management, we all know there are certain facilities, there are certain process. First of all, it needs to be collected by the municipal authorities. Once it gets collected, it needs to be segregated. Once it gets segregated, then it can be incinerated or maybe non-incinerated, and then again it can be recycled. So there is a fundamental process to follow this. But in case of particularly for plastic waste or for plastic component, as you can see in this figure, we have used PET bottles, we have used some HDP products, we have used these PVC pipes, LDP. So just to give you a reference, there are 7 categories of plastic waste. I know you must be aware of it, but to just give you an idea, so the first one is PET, the second one is HDP, the third one is PVC, LDP, PP, PS, and others. Each of these category basically has its own strength and weakness. So they have been designed in such a way based on the polymers. So let's assume the PET is developed from a polymer which does not lies in PVC. So PET can be only used for particular quality of production, while PVC can be only used for a particular grade of production. So that's how these two are very different. So in this figure, you can see how value-added products has been extracted from it, and then how the treatment facilities has been followed for this. Again, once you have recycled everything from the plastic, you need to also reuse it. It's very essential. So there are some examples over the years the researchers have worked on. The first example is the plastic to road construction. This is one of the most trending thing that has been into the highlights over the years. But certainly, if you ask me as a researcher, I'm slightly worried about this, because if you're using it for construction work, again, you are developing a new material, because plastic itself is a polymer, it's a new material, and you're combining it with the construction based material, it's a new material. We never know after 5, 10, 20 years what kind of emission we will get out of it. So again, we are getting rid of plastic as of now using this kind of work, but we never know in coming future we will have more consequences coming out of it. The second one is the plastic to liquid RDF. So RDF is somewhat a proven technology. So to give you an idea, RDF, it's a refuse derived fuel. So again, it's a part of incineration. Just burn it, a gas will come out, the steam will come out, you will use it for the electricity production. So it's a proven technology. But again, do we have that quality of plastic product coming out of it, that quantity of plastic product coming out of it, that our incineration plant can work efficiently? Because the problem with the incineration plant is the economics. You need to have this much input to it to get this much output from it. So again, if you do not have enough feedstock on daily basis, you can't have that much production. Then the third one is the conversion of PET bottles into textile products. So again, this is also one which has been practiced over the years. But again, you have transformed it into a textile product. You're using it for stitching purposes. You use it for your shirts and t-shirts as of now. But we never know, when you try to recycle it again, it won't be able to recycle. So again, we never know what this method would go in. Finally, plastic to toilet, pavement blocks and all. So again, this has been also the proven technology. It can be used for the pavement blocks. And these are the simple things that can be done. You can see most of the YouTube shorts you can watch that how people have started their own startup producing these kinds of pavement blocks. So coming up with the construction and demolition waste. So construction, we produce around 10 to 12 million tons of waste annually. Out of 4,000 tons of C&D waste and 2,000 tons of waste is being dumped annually. So That's what are the things to be worried about. So what does it comprises of? What does the C&D waste comprises of? How it is different than rest of the category of waste? It comprises of concrete, it comprises of metal components, it comprises of woods, it comprises of soil, sand, and gravels, which is one of the major proportion, around 37%. Then bricks and machineries, which is around 32%. So these kinds of grades, these kinds of categories need to be extracted, need to be recycled, and it need to be reused. The good thing is that in past few years, there has been certain recycling facilities which have successfully been working in regions like Delhi, Bombay, and they have been economical viable also. So this is some of the example how the things get demolited, and then it get again transported, and then again it get reused. So over here it was a demolition phase. Again it's get demolited, and then it get transported, and it get used for the highway and landfilling work. So that's how the thing can work. And its recycling process, it comprises of manual separator. Because once the building, once the infrastructure get demolited, all the category of waste get mixed into it. So once it reaches a recycling facility, it need to be screened out first. It need to be segregated first. So this is how the C&D waste sector works. Coming up with the hazardous waste, again we have already talked about it. Hazardous waste, the category of hazardous waste from where we usually find this kind of waste. So landfillable waste around 2.26%, while the utilizable is around 44%, while the recyclable hazardous waste is around 27%. So this is how the different categories of hazardous waste has been. It has been around 10 million tons of hazardous waste getting generated in year 2020-2021. And it's really very important how the states are working with. There are 512 units utilizing hazardous waste, having authority of capacity of around 37 lakhs tons per day maybe. And nowadays what the new policy for hazardous waste management has come out to be is that let's assume there are 100 such companies producing hazardous waste. So for this 100 companies, there are going to be a common company who will be handling their hazardous waste. So now whatever the tipping charges is a fee that all these 100 company will be giving to a single company to handle their waste, is going to do that. So now we have also these kinds of policies by the government to reduce hazardous waste disposal into normal facilities. So it's the best thing that over the year the government have looked into. So this is again some stats how the quantity of hazardous waste has increased in different states. And as you can see, Gujarat is one of the leading one, because most of the industries are in Gujarat, followed by Maharashtra, then in Tamil Nadu. Maybe the stats may slightly differ, because over the year I have seen Uttar Pradesh and southern region has been more into like industrial sector. So there must be a spike into these ratios. Coming up with biomedical waste, again, India is very big. We produce around 800 tons per day of biomedical waste, and we are hardly able to treat 600 tons of waste. So there are states which produces maximum biomedical waste. Maharashtra is one of them, around 8,000 tons per day. Kerala is 6,000 tons per day. And believe me, during the COVID time, these values were approximately 5 to 10 times more. So again, to handle these facilities were very difficult to do that. So you can see over here, I've already mentioned non-COVID biomedical waste generated, COVID-19 biomedical waste generated, how the value got substantially doubled approximately. It was initially around 600 and then it reached around 1,000. So that's what the different arises. So that we need to have a different biomedical facility compared to the normal solid waste management facilities in every cities or states. So this is how the things work. Again, the first idea is to minimize the waste, minimize the production of waste, then segregate it, collect it, transport it, sorting, treatment, and disposing. This is somewhat similar to what we have seen initially. And the common technology which is preferably used for biomedical waste treatment is the incineration. It is the best incineration facility we can have. In country like Japan, who is one of the pioneer in the domain of incineration development, they have brought a concept of on-site treatment. So now each hospital will have their own small incinerator where they will be heating their waste. They will be treating their waste in their hospital premises itself. So India is still behind implementing these kinds of policy, but maybe in coming in future we will be doing it efficiently. So these are some of the stats. These are some of the central facility for biomedical waste treatment. As you can see, Andhra Pradesh, Gujarat, Karnataka, Maharashtra, we have most number of facility. But I am not sure that how much it will be retaliated or it will be justified with the kind of production hospital facility which we have, because we have hospital facility more than 10,000, 15,000, 20,000 in each city. So are these facilities, treatment facilities efficient enough? Apart from this, are these treatment facilities working efficiently? If there are 30 facilities, are all 30s working efficiently on daily basis? It's again a part of question which a solid waste management treatment has been over the years. Some basic treatment methods. One is the composting, vermicomposting, anaerobic digestion, incineration, and sanitary landfill. These are the conventional treatment methods which we use it for the solid waste treatment. Some of the recent technologies development which we have found is the pyrolysis technology, RDF plants, gasifications, and bioreactor landfills. So these are some of the upcoming technologies where the R&D is going on. Some status of technology across the globe. As you can see over here, uh, based on the income, the landfilling has been mostly preferred in upper middle class income countries. So we are into the upper middle class country like India. While in terms of low income countries, you can see the higher percentage is for the open dumping. So that's where the problem arises. We directly open dump it. So currently, in most of the countries like India, cities in India, we also do this, in the same way. While in case of the region wise, you can see the purple color one in North America, that is the recycling. They prefer having recycling the most and then landfilling, but they have the engineered landfill site. So what is this engineered landfill site? So these landfill sites are well managed. Once you will move around in the landfill site, you won't feel like there is a landfill into it. There are waste dumped into it. They are so well managed. They will just look like a garden place. So there will be a provision for leachate collection. The liquid coming out of this waste, there will be a separate provision to it. There will be a gas emission control system. The gases coming out of this landfill site, because again, this landfill site will be totally covered up with the green grass. So every now and then the gas gets produced inside this. So this gas will be collected through a different system. So we call this kind of system a proper sanitary landfill site, engineered landfill site. So this is what US does it. While in case of the South Asia, you can consider India into South Asia. We use composting the most. We use composting, and then we prefer having somewhat anaerobic digestion the most. While in case of the East Asia, the things are different. Again, landfilling are most preferred. So depending upon the country's economical background, they have their own treatment approach to it. So some of the major research area in SWM management and circular economy, it's important that we have an integrated system to optimize a process parameter, to introduce different combinations, to have new design sequencing for these technologies. And we need to also have a life cycle assessment based system. So if you need to know what is the carbon emission coming out of a particular management system, we need to have a life cycle assessment tool. We need to have route optimization technology. We need to have proper monitoring system. So this is, if this gets integrated to the solid waste management scheme, we will have a concept of circular economy where we will be able to reuse and recycle everything once now and then. So again, as I talked about, we need to have integrated policy in terms of national policy, in terms of legal framework, in terms of financial management, in terms of participation of public and private sectors, in terms of appropriate technology, depending upon how economically viable this technology is. Finally, the institutional arrangements. We need to have participation of schools, colleges, R&D institutes to have a better technology, to have a better understanding, better transfer of information from a small scale level person to high level official sitting into the system. So this is some of the effective circular economy schemes over the year which I have seen, that how these countries have been managed. So there is a need to have institutional arrangements, appropriate technology. Again, I have talked about it. We need to have a proper scheme. We need to have guidelines. A national effort is required where we need to follow Supreme Court's guideline, SWM rules. Now we have SWM solid waste management rules. So those who are unaware of it, just go through it. We had its first edition in around 2002. Now we had it in 2016, and we again had it on now 2024, I think so. We have 3 editions of SWM rules. Just go through it, just read what is the new rules, new policies, see whether your residential colony or your home practices it or not, or your ULB practices or not. And based on that, we need to identify the problems. We need to have a strategy to improve it, and then we need to come up with the R&D objectives and its solutions. So again, need to have interactive decision-based system. Actually, the private sector and municipal organization need to have an interaction with public awareness. We need to spread public awareness about how the waste is, how it need to be handled. The objective should be to have proper human interaction and proper dynamics and flexible solution to it. While at the same time, we need to also have strategical planning, and we need to have technical resources. Currently, in country like India, we lack infrastructure. We don't have technological infrastructure. We don't have enough composting plant. We don't have enough transfer station. We do not have material recovery facilities. So again, material recovery facilities are an intermediate facility where the waste gets segregated, or the one which gets discarded from the houses. So we lack this kind of infrastructure. So the proposed area, the best area is to work on the policy framework for solid waste management. The second one is the technology, and then the formulation of measures and organizing these in a structured way. Some research, there are some research findings also that you can work on. Some research gaps also we can work on. You can work on spatial technology. So what is this spatial technology? We can use GIS based or route optimization system to predict or maybe to monitor how is the collection scheme going on, how is the waste generation scheme going on. We can also have some R&D on treatment technologies, some emerging treatment technologies. Let's assume incineration, pyrolysis, microwave technology, whether it's feasible for Indian context. If not, how it can be. Can we have some techno-economical analysis study on it? Further, the most important thing is that we lack the data. We don't have data on daily basis. We don't have a centralized portal from where we can extract data on daily basis, what kind of collection, what kind of treatment, what kind of sorting things we are doing in waste management segment. So we need to have a common portal where all the data gets segregated and gets compiled on day-to-day basis. Secondly, we need to have some prevention-based schemes also. We need to have certain technologies which can avoid having this. We need to have AI and ML into this. So now, recently I was working with one of the organizations. They are trying to come up with a model which will estimate, which will have a data for a year from your city, that what is the solid waste getting generated from which area. And after 1 year, it will tell you what will be the quantity of waste coming out from this area after 10 years it would be. What kind of waste classification or the waste trend will change over the years. It will estimate initially itself. It won't wait for 10 years to see what kind of changes it has been. You can use image-based recognition system to monitor whether the waste has been discarded onto the open space. People usually come in our city and they will throw their waste into the streets. So we can have an image recognition system. The image will identify, the AI-based image recognition system will identify, and the fine will be directly deducted from the person's account. We can do that because smart technologies is a part of the smart city development program. So again, can we have these kinds of technologies? So these are some of the R&D gaps. Maybe in future, the researcher like you and me and rest of our can work together and we can come up with the probable outcomes and some new technology. So ultimately, some of my key takeaways, try to come up with a technology, bridge the gap of solid waste management with the technology, and that's where our future is actually. We need to have smart technology for solid waste management. Some of you can also follow me on Google Scholar. I have worked on different aspects of solid waste management over the years. I have some good publications record over the year in these areas. I've been constantly working on technology development, policy framework, circular economy, anaerobic digestion, biogas production, biohydrogen production. You can just follow me for my updates, how my work is going on over the year, and maybe if it can inspire you, maybe it will be value addition to your knowledge. I would be really grateful to hear that from you. Finally, anytime you can just follow me on LinkedIn, or you can get in contact through me via email, and I'm open to the Q&A session with you. Thank you so much for hearing me out for so long. Thank you.
Hello, am I audible?
Yeah.
I had a question, but before that,
Mhm.
I wanted to say that I feel like you did a very good job with the whole presentation because whatever question I came up with was answered directly in the next slide. So I wanted to point that out. That was a very good addition. It was different.
Thank you so much. Thank you so much, Aditya.
Other
Please
than
go ahead
that,
if you have.
Hanji, I had one or two questions. First thing is, say you spoke about India ranking quite high in generation of e-waste and generation of, let's say, plastic waste, and how some systems are not being, what's the word, are not being followed at lower levels. There might be mismanagement, etc. Certain issues, right? But like, what are the economic barriers or like barriers of entry, hota hai, something like that? What are the barriers to India being able to do this effectively? Let's say, like a nation like America. What is the big difference, so to say?
So here comes the most bridging and most what I can say. First of all, it's a very good question that how we can reach that benchmark. Okay, that's the problem we have. How we can reach. So that's what your question is. So it's very important that we look into the product design specifically. The problem with the country like India is that for example, I want to do a business. I would start my business. I can have a company overnight. I can have my product anywhere from India in any form. As of now, it fulfills the basic criteria. My product is online. You can just sell it anywhere. You can sell it on Amazon. You can sell it on Flipkart. There is no such design criteria. There is no such product quality criteria. So that's the first thing. I will just give you an example. Way back during my BTech, I was just reading this book from written by Steve Jobs. Actually, he's an Apple founder. So when he developed his first Apple iPhone, he realized the phone motherboard was not looking very good. So he asked his team that we will postpone the launch. You just make this motherboard very critically viable in the terms of looks. So the idea behind was it to make it sophisticated. It should not look crowded. It should be easy to nullify. It need to be easy to extract once we recycle it or reuse it. Ultimately, it became beautiful, and that's how the product designers in India need to look at it. We have n number of companies, but there are no such design criteria. The first thing is that. The second thing, if you look into high quality of product, it's going to be expensive. And again, country like India can't afford such expensive goods because we have people from different economical barriers also. So that's one of the problems. So maybe we can have some policy schemes implied on manufacturers rather than the consumer. So that's what ERP. I don't know whether you are aware of it. So it's ERP, extended producer responsibility. So now let it be any of the company. If you are producing a particular product, it's going to be having certain kind quantity of waste generated every now and then. So now it's your responsibility to recycle it either by yourself or either by the third party. So maybe this is the way that we can again look into this, but it has been hardly 2 years. I don't know how well it has been aligned, but hopefully we will have it.
Thank you, sir. Can I ask another one?
Yeah, sure, please.
Okay, so you mentioned, okay, the slides mentioned a lot of informal aspects, like it's say informal dumpsters, informal landfills, and so on. But I was wondering, wouldn't having all of these informal aspects be, let's just say, harmful after a couple years in the long run, so to say? But
It
like,
has been. It
ho-
has been actually.
it
It has
has been.
started actually. It has
But
started
then, how do
actually.
you deal with those? Like, again, policy making is a good way, of course, but how does that happen?
So we need to understand this informal sector. They are from different. Mostly they are from lower income category people. So I will give you one example. I will give you just example because I was in year 2018 to 20. I was at CSI and Niri, and I was lucky enough to work on a project sponsored by DST. So at that time it was the only project on landfill being sponsored to manage its landfill fire management. So I was completely working 6 months on landfill. I had my master's topic into it. So over there, we used to interact with this informal sector very now and then. We used to collect samples. We need to collect data. So out of 24 hours, around 12 hours, we used to be there itself. So we have consumed a lot of methane now. So the people over there, we asked them, Bhaiya, can you take this sample which we have collected to that spot? we'll give you 50 rupees. That bhaiya said, it will take 15 minutes for me to go there and come back. At that time, I will earn 100 rupees over here. Just by segregating that waste. And they have their own legacy. I have interacted with this informal sector. The older, the person at the high end of the hierarchy of the informal sector, for example, I am the boss and I am some high-end manager level in the informal sector. I will work on landfill side, which has got more returns, and you will work on street. So inside they have hierarchy. So currently they are working themselves. That's why they are maintaining this hierarchy. If we club them, if we try to merge them with the formal sector or with the ULB and we incentivize them, okay, whatever you earn, it's yours, but we will also give you incentives. We will also give you training sessions. If it's possible for you, just visit this Tata plant in Jamshedpur. The Jamshedpur ULB has given its complete power. Actually, I've been working with them, so I've been in touch with them. That's why I'm able to share this with you. They have completely handed over everything to Tata. Now, what Tata has done, Tata have made this informal sector their employees. That, okay, we are collecting waste, you collect it from our behalf. Whatever the incentive we will give you, the monthly allowance we will give you. So they are happy to work. So some ground level, maybe some ULB level schemes will be just see some scheme 2 times. Maybe they will get excited and they will work together. This can be one thing that we can plan actually. But again, lot of constraint. Working with the ULB is very difficult. They have a lot of. I've done with ULB. ULBs, ULB Bombay I've done, and I've done with Nagpur. They are very difficult to work. Believe me, they won't give you a single penny of data.
Did you focus on primary research for your PhD?
My area of work was in 2 segments actually. So the broader area I will just explain you. We have this littering activity going on in our city. So there are a lot of litters everywhere. So in ULB, if you look HWM rules, there are no specific policy to counterpart this litter. There are no such rules. So basically, we need to have some strategy, some framework to evaluate whether our city is prone to littering or not. So I have developed a framework where we can evaluate. Using this framework, you can evaluate how much percentage your city is litter prone. So my first part of my work with the secondary data, primary data, and then I have validated it with the secondary data.
That sounds very interesting. Thank you for the answers.
Thank you, Bob. I hope I was convincing.
Yeah, very. It was quite a good answer. Someone has any other questions? The floor is yours.
I can see one hand getting up. Purity.
Yes, thank you. I am Purity Kerubo, a student from Kenya, Meru University, pursuing Bachelor's of Technology in Electrical and Electronics. And well, I have been thinking maybe it is possible to do a project on how we can turn like sewage water, if it is possible to treat sewage water and then use it for like producing electricity. We run it through some like higher distance, and then we run the turbines and then to produce electricity. So I asked one of my friends and he was like, it thinks it can happen, but it thinks like it is a complex project. So I don't know, maybe if you can advise further now that you are.
Actually, my first question was about to be that at what level you are planning to do your work. So I will give you an example. So there are TRLs level, technology readiness level. So now the topic which you have said actually is a part of technology development. So you need to first understand what TRL level you are targeting. So you are targeting TRL level 1, 2, 3. So TRL 1 and 2 is something like going into literature, seeing what technology is. TRL 2, 3 is something like doing it on bench skill level, doing it at lab scale level. TRL 4, 5 is something doing it at a prototype level. 7, 8 is something like implementing it on field and testing it And finally, 10 is something like it's marketably available. You can just sell it. You can just use it in market. So first of all, understand at what level you have to work, whether it's going to be at the initial level. Are you a bachelor's student or a master's student?
Bachelor's.
You're a bachelor? Okay.
Yeah.
So the best thing I would tell you, actually, you just try to get in contact with people who are all before that, what I can understand, you are trying to work on biogas production. Yeah, is it? Because if you produce biogas, it's a high-end energy fuel, and then you can use it for electricity. Is it? That's what you are targeting, na? It's better.
No,
yeah.
Like you know, like biomass has already been done. The biogas thing has already been done, but now, like, what if we use it? Like, we make it like a little different. We treat the water first. That's one way of recycling. Then now we use this water to produce electricity, like hydro now. But now the sewage water itself.
Okay. So again, now it has its own complications. See, it's not that easy, actually. It's not that easy. So if you want to produce electricity, it's certainly a different science behind it. I will just recommend you to first try to get in touch with people who are working in this domain. Try to do a raw field work. Maybe you can do an internship with companies working on these kinds of electricity production from steam and all, from water and all. Once you get experience from that, do it. First of all, do not do it at batch scale level. Do not do it at lab scale level. Do it on a theoretical level. I will give you an example. Let's assume you want to take sludge, na? You want to take sludge. Take it as a takeaway task. How much kg of gases will get produced from 1 kg of sludge? Just go and estimate it. Because whatever will get produced will help you to produce electricity. What are the conversion losses? Once you know this value, now start doing on conversion losses. Just look into what will be the conversion loss. So there will be water vapor loss. There will be pressure loss. Okay. There will be some technology losses before it gets transferred to the technology, whatever gas or water you produce. So just do some theoretical work. Doing this will take you 6 months. So maybe this can also be a good, maybe a bachelor's product. Once you get a good something outcome, then the second stage, if you have still time, let's assume you have done it for 3 months. You have done this for 3 months. Okay. Now you have 3 months left. What you can do, there are certain simulators. There are some free softwares which can help you simulate these conditions. Okay, just go through these softwares. One such software is maybe you can look into Aspen. Aspen is one such software. Use Aspen for your simulation. So basically, simulation is an artificial way of illustrating its field working mechanism. Okay, so for example, in real time, you will be having a reactor. From there, you will be burning something. It will be gas coming out of it. So initially doing it physically, let's simulate it in software. So the second stage will be to simulate in software. 3 months you can do that. Once you have done this in 6 months or 1 year, your bachelor work is done. Now you find this work to be good enough. Go for your master's and then do it for batch study. This is what I would recommend.
But right now I am at my industrial attachment in a geothermal power plant, and I think like if you put more effort into it can work actually.
Yeah, it can be, but it's equally important how you strategize your research plan. It's really a part. It's a very important part. If you work randomly here and there, you won't get a source point of objective. It's very important to come up with an outcome, a value addition outcome. For example, I'm using this cell phone. I'm keeping it this way. And why keeping it this way? I have a strategical understanding to keep it in this way. Why the camera is behind this phone? Why it is not ahead of phone? So just think in that way. Okay. You people are great minds, but just need to be streamlined.
Yeah.
Great understanding. All the best.
Thank you.
Would you give to someone pursuing either a career or doing a research in sustainable urban development, or else environmental engineering.
Okay. So is it in terms of research or just in which way you are? Is it something like job opportunities or in research? So that way I can answer it.
Research.
Yeah. So research again, the first thing is that at what level you are trying to do that research. It's very important. At what level? For example, she was from bachelor's, so a certain level is designated to her. Secondly, the area. It's very important. The first thing to choose an area of research is to look into some localized problem. It's important that you look in your area, in your city or town, what the major problem is. Let's assume a small example. During my master's, I wanted to do my master's thesis on water wastewater. I wanted to do on photocatalysis. But I went through the literature. I came to know there are already existing technology, and I came to know that most of the people have done. There is already a sewage treatment plant working with this technology. What is the use? So I looked into different problem. I found that landfilling is one of the problem. The fire gets emitted into this landfill site is a problem. CO2 coming out of it is a problem. So I started to work on it. So the second step will be to identify the localized problem level at localized level. It's very important. Third, the economical barrier and the resources. Look into whether that work is feasible to do it at a local, with the resources that you have, with the financial constraint that you have. If you can do that, just take it. Fourth comes your mentor. It's very important. You need to have good mentor. Without a good guide, genuinely good, you won't be able to excel it, because he will be the one who will be able to get things associated for you. He will be able to turn you around with when you hit some obstacle. He will be able to want to do that. So just follow this 4-5 scheme. You will be able to do that. And fifth is obviously your interest, your zeal, your hard work. So maybe this can help you out. This is more than sufficient.
Okay. Thank you.
Most welcome. I hope I was entertaining to most of them, and please feel any time to get in touch with me. Apart from the topic which I have discussed, anything around it, something here and there, I would be happy to help you out. And again, thank you to Pahal organization for having such a beautiful platform to interact with young minds like you.
I think we're done with the questions for today. So just to conclude today's session, I'd like to thank you, Dr. Singh, for the extremely informative session that we've had today on the circular economy around waste management. It was an absolute pleasure having you here speaking to us. I found it very informative. And I'm sure many of us are walking away with, let's say, a much better understanding of how waste management works. I'd also like to thank all the students in attendance and Mercy herself for helping me facilitate the session. That's it. Thank you.
Thank you so much. Thank you so much, Aditya. Thank you. Thank you, Marise. Thank you.
Thank you.